Students.
Good morning, sir.
Yes, very good morning, ma'am. Yes. Shall I start?
Yes, sir.
Yeah, my voice is audible.
Yes, sir.
Okay, 1 minute, ma'am. This PPT is visible. Yes, someone has to give the response.
No, sir.
PPT
It's
is
not visible. No.
PPT is not visible.
No, sir.
No, sir.
Now PPT is visible.
Yes, sir.
Okay, thank you, ma'am. Yes, good morning, one and all. Jai Shri Gurudev.
Good morning,
So
sir.
our next lecturer video is a lecturer number 4 in the mechanics of materials. Right, we studied in the last week we studied what do you mean mechanics, then mechanics of materials. So what do you mean stress, then types of stresses, then strains, then types of strain, then stress strain diagram. Right, and then also we discussed about Hooke's law. Right, so Hooke's law states that in the stress strain diagram you can see that stress is linearly proportional to a strain within the elastic limit. Within elastic limit, stress is linearly proportional or directly proportional to a strain. In order to remove the proportionality, we need a constant. That constant is called as constant of proportionality, or also called as a Young's modulus. Right? Okay. The proportionality constant is also known as Young's modulus. Young's is a scientist's name. Modulus is nothing but is a constant or is a modulus of elasticity. As you know that Young's modulus is equal to is the ratio of stress and strain. Right? Its unit stress unit is Newton per mm square. Strain there is no unit. That's why Young's modulus also we represent is Newton per mm square. The symbol, what will symbol we use for Young's modulus is capital E. Now also we discussed about the engineering stress and strain and true stress and strain. Engineering stress, as you know, the stress are nothing but the mathematically we can represent it as load by cross-sectional area. Here, what is the cross-sectional area you consider here? Original cross-sectional area. True strain, true stress are nothing but is an instantaneous load. Instantaneous nothing but at particular time what will be the load acting on the component. To the instantaneous cross section means at particular time once the material get deformed, what will be the cross sectional area at that time, that we can say this true stress. But in for a theoretical analysis always you consider engineering stress. Now true stress will not consider because each time the load is varies and each time the cross sectional area is varies here. We can't measure at particular time what will be the cross-sectional area. That's why we'll go for use engineering stress and strain diagram, and engineering stress only we used. Now today class we go for explain what are the material properties. So material is nothing but if you take any substance is made up of okay, any component you can take that it is made up of substance. The substance you call as material. How do you choose the material? Based on how the material behaves when it is subjected to an external force. How the material behaves when subject to an external force. That property we can call as a mechanical property, right? Other than mechanical property, if you go for chemical property, chemical composition. For example, if you take water, what is the chemical composition of water is H2O, right? Two molecules of hydrogen, one molecules of oxygen, when combined each other, then you get a water. That is a chemical composition. When you go for that is a chemical property. When you go for physical property, the physical properties are density, is a mass density, right? Mass per unit volume or conductivity and other things are there. But for mechanical or aerospace engineering, we mainly concentrate on only a density here. Next comes to mechanical property of the material, nothing but when an external load acting on that material, how the material behaves. How the material behaves. The study that shows the property called mechanical. When we say mechanical means an external force is there, or then when external force is applied on the body, it tends to resist that force or it tends to change its position or deformation. Means force into displacement is called as work, right? When physical work takes place, then you say the mechanical, right? When it comes to mechanical property, you can see the strength, the toughness. In detail, we'll discuss this one in later. Okay. Next, later material properties and dimensional property. Dimensional is nothing but is a size, how much length it is, how much width, height, and then what shape it is a circular, rectangular, square cross section. All the things you can see in the dimensional property, right? So out of which is very important here in our subject mechanics of material, we'll discuss only the mechanical property. Now comes to mechanical properties of material. When we say mechanical property of material means a material is subjected to an external load. Any object you can take here, the object is made up of substance or material. When it is subject to an external force, how the body behaves, that we should know. Why we should know this property? If I know how the body behaves when subject to an external force, based on that we can use that material in an equipment or in an machineries or in any other devices you can easily use if I know the behavior, right? Best example, if I know how the plastic behaves, how the wood behaves, or how the metals behaves when separate an external load. Based on that, we go for manufacture the component. For example, chairs. Again, chair, sir, again made up of earlier we use a wood. Later on stage you can see the metal, right? Mild steel. Then now you can see the plastic chairs, right? If I know how the material behaves and is subject to an external load, then you can use that material in our to fulfill the condition, right? So these are the mechanical properties. The first important property is called as a strength. How do you define a strength? It is related to stress only. Okay, when you go for stress strain diagram, you can see that yield strength, yield point. At that yield point, you'll get yield strength. At ultimate point, you'll get ultimate strength. At fracture or rupture point, you'll get fracture strength. Now, what is strength is related to? It is related to only a stress. Now, it is the ability of material to withstand the maximum stress before undergo its failure. Then it is called as a strength. Okay. Okay, so first I'll explain that what are the mechanical properties. First one is strength, stiffness, elasticity, plasticity, machinability, ductility, brittleness, malleability, toughness, resilience, creep, fatigue, and hardness. Again, so many other mechanical properties also there. Here we listed only few here, and these are also very important mechanical properties. Total 23 to 28 mechanical properties are there, out of which we discuss only very important here. Now the first one is strength. So in general, you can see the strength.
Excuse me, sir.
Yes.
Sir, we cannot see the slide which you are explaining now.
Okay. What about remaining students? Is all of you are facing same problem?
No, sir.
Sir.
Slide we can see, sir,
Yes,
but the
sir.
PPT we can see.
PPT you are
Slides.
seeing,
Yeah, but this slide which you are explaining is not been seen.
not visible. Okay, 1 minute. Now it is visible.
No.
The
first
slide
slide.
is, yeah,
Only the-
mechanics material, right?
Yes,
Okay,
sir.
1 minute now. So I will move the slide.
Now it's coming.
So it is visible.
Yes, sir. Yes,
Yes,
sir.
sir.
Slide is mechanical properties of materials, right?
Yes, sir.
Now I'll move the next slide. Now it is also visible.
Yes, sir.
Yes. Okay. So sorry. Now it is visible. The slide is
sir.
visible.
Yes, sir.
No.
Yes, sir.
The first one strength it is. It represents as strength, right? Okay.
Yes.
Shall I start?
Yes, sir.
Okay. Now the first mechanical property, most important property is strength. Before going to give the definition for that, now you itself you feel that strength. What do you mean by strength? So what is our strength? Okay, you can see that in our in your batch, we can say your strength. What is your strength of batch means? We can say in general it is 28, 29 members in a numbers are there, right? Instead of that, you can say in individually you can say what's your strength? I'm strong in this. I'm strong in this, right? So strength that shows your ability, here also the material concept here, the ability of material to resist the loads without undergoes failure due to excessive stress. Okay, the ability of material to resist the loads without failure due to excessive stress. As you know, the stress is nothing but load by cross-section area. That is Newton per mm square. We can represent. The unit is means what is the maximum stress the material can withstand before undergo its failure. That we call as a strength of the material. Best example, if you take, you suppose a person is lifting the weight, for example 50 kg, he can easily lift because his mass also maybe 60 or 70 kg, he can easily lift the 50 kg. Suppose if we say the same person lift the 100 kg of weight, 100 kg of rice bag, person not able to withstand because its strength is not there. Means what it shows, it is the ability of material or ability of the person to resist the loads without the failure due to excessive stress. That you define as a strength. What is the importance of the strength? It refers to the material resistance to failure by fracture or excessive deformation. Suppose if you are conducting a tensile test, if a tensile load acting on that material, if it is before going to its fail, what is the maximum stress the material can takes here, the material can withstand, the maximum stress the material can withstand, then you can say the tensile strength. Okay, please switch off the video, ma'am. Someone is switch on the video. Yes. Okay, thank you guys. Next, suppose if the material is subjected to a compressive load. First one, if material is subjected to a tensile load, what is the maximum load maximum stresses that induce in the component before undergo its fracture or failure, then it called as that maximum the strength the maximum stress the metal can withstand is called a tensile strength. Similarly, if compressive load is occurred on the component, occurred on the material, what is the maximum the strength compressive strength maximum compressive stress the metal can withstand before undergo its failure means fracture, then it called as a compressive strength. Similarly for shear strength, similarly up to yield point you consider it called as a yield strength, up to ultimate point you consider ultimate strength, then up to breaking point you consider here breaking strength. Last one, fatigue. Fatigue is nothing but is a cyclic load. Here what we have applied here is a tensile, compressive, shear. Those are called as a steady state load. Means the load does not changes with respect to time. What is the velocity at which we are applying a load is constant. That is called as a steady state or static load. If it comes here, some components are rotating, accelerated, rotating shafts. If you take a fan, if you switch on the fan, it start from 0 speed to at required speed, it is accelerated, right? Then it comes under what type of load? Cyclic load. For cyclic load, we call it as a fatigue. Okay, later we'll discuss. One is also one of the material property. Then if before going to failure, what is the maximum stress it can withstand due to cyclic load? That strength is called as a fatigue strength. So why do you want to know all these strength, all these values means all the material strength means because before undergo its failure, how much stress is the metal can withstand, that we should know. Best example I can give the chair, plastic chair. A one person can easily comfortably sit. The plastic chair can withstand that load. So at a time, if 2 or 3 persons can sit on the plastic chair means the plastic will not withstand that load. It will collapse. It will break because what is the compressive stress of the plastic chair is not that much value. It will not withstand that whatever the load acting on the chair, plastic chair. That is the compressive strength. If you know the compressive strength, we can easily define the how much load, how much stress it can that chair can withstand. That's a very important material property. And also, if you go for design any component, okay, if you go for design against strength, then you should concentrate this very, very important material property. When you apply a load, whatever the stresses induced in the load, the stress should be less than the yield strength or ultimate strength. Then you can say the material is with the standard load. That is design against strength criteria. Okay, and later I think if you have in the 4th or 5th semester subject, design subject, we come to know that. Even your mom mechanics of material also will study that design against strength. The second most important property is called as a stiffness. Stiffness are nothing but we say that we are more stiff. So suppose there are some person we can say that so is a more stiffened body means what it means is not ability to deform, is not able to change its dimension. When external force is applied, the material will not resist to and material will not undergo any deformation. Then you can say the material having more stiffness. The ability stiffness is nothing but the ability of material to resist the deformation due to load. That we call as a stiffness. How do you mathematically represent stiffness? Stiffness is nothing but load per unit deformation. The representative stiffness is K. Load is either you can use F or P symbol in Newton. Deformation in millimeter. What is the unit of stiffness? Newton per millimeter. Okay. Next, it is also called as a rigidity. Why do we call it as a rigidity? Means the material does not undergo any deformation when you apply a load. That is the means rigidity. Rigidity is nothing but a body which does not undergo any change in dimension. That body is called as a rigidity. Next, what is its importance? A stiffer material undergoes a smaller deformation when subjected to a load. Okay. There is a second very important property. First important property is strength. Second one is important property is stiffness. Suppose if you design a component based on against rigidity. Rigidity means whatever if you apply a load on the component, suppose component is undergo some deformation. Whatever the deformation in the component, that should be less than the allowable deformation. Then you can say the designed component is safe against rigidity. These are the two important criteria when you go for design any mechanical element or any aircraft component. These two things are very important. One is design against strength, another one design against stiffness, or design against rigidity we call as. The third one is hardness. It is the ability, it is the measure of resistance to surface penetration or indentation and abrasion. For example, if you take a component is more hard, best example for hardness I can give the car body. If a car body, if you go for any object, if you go for on the place over the car body, if you press it, what happens? Initially it resists. After that, what happens? A dent occurred here. Now, how do you measure that properties? With the help of the term is called as hardness. Hardness is nothing but it's a measure of resistance to surface penetration or indentation or abrasion. Another best example, if you take once you fired the gun, the bullet and pierce the object or pierce the body, means the hardness of the body is less, we can say that. That is the importance of the third mechanical properties is a hardness. Next one is ductility. Ductility means that shows when you apply a load on the body, it continuously deform. When you apply a tensile load on the body, the ability continuously deform. Example for ductility means take wires, electrical wires. If you apply a load here, or if you take best example, elastic rubber, a rubber band. If you go apply the load on that elastic rubber or rubber band, it continuously deform. Then you can say that material is having which property? It is ductility property. Malleability means if you are, instead of applying tensile load, if you apply a compressive load, the ability of material to deform under compressive load. Where you apply this compressive load? If you want to make a thin sheet or plates, right, or coils, if you want to make coils of thin sheets or plates, then you go for the material should have this property, malleability property. Next, elasticity. Elasticity means if you apply a load on the material, it continuously deform. If you remove the load, it comes back to original shape and size. That property, material property called as a elasticity. Elasticity is nothing but is the ability of a body undergo a deformation when the load is applied and return to its original shape and size when the load is removed. Best example, take a spring. If you apply a load, compressive load or elastic load on the spring, if you remove the load, it comes back to original shape and size. Similarly, elastic rubber also. If you apply a load, the tensile load, again if you leave the load, it comes back to original shape and size. Now you can say the rubber has this property, elasticity property. Next, plasticity property means when you apply a load, it continuously deform. If you remove the load, it will not come back to original shape and size. That property is called as a plasticity. Best example for plasticity, you take any plastic bags. If you apply a load, tensile load, if you remove it, it will not come back to original shape and size. That is called the metallic or plastic chairs. You can see how the metallic or plastic chairs are made. Metallic chairs, you can see there is made a curve, right? The bend shape. Once it is undergo what state? It is plastic state. If you take a pipes, tubes, they are also called as metallic tubes. That also undergoes a plasticity state. Means the ability of material undergo permanent deformation without breaking or rupture. Right? Next, now the eighth property is fatigue. Already I told that fatigue is nothing but when now instead of applying a static load, a cyclic load is there. What is the maximum stress a material can withstand under repeated or cyclic loading? That is called as a fatigue. Example, rotating shaft. Instead of rotating shaft, suppose if you have a pen, like what you call as this type of pen. Okay, the spring is the pen contains a spring. If you apply what is the opening and closing there, continuously you are applying. That is also called as a cyclic load. Then what is the maximum stress that material can withstand under repeated cyclic load? Now always the material will fail in the fatigue is less than or below the yield strength of the material. Now other than this, whatever the remaining material properties are there, the material fail above the yield strength or ultimate strength. But except fatigue and creep, these two are the metal fails below the yield strength of the material. Next, last one is creep. Creep means nothing but it's a time dependent property. That is ability of material to deform permanently under the influence of mechanical stress. Best example I can give for creep is take a structure, civil structures, buildings. Now, if you construct a building, after 20 years or 30 years, you can see the building or you can see the church or bridges. Slightly, whatever the building is, it may be it's not able to withstand the stress. Means it may be a crack initiation, crack propagation. Finally, the building may be slightly bent or whatever that the walls. Okay, they may be damaged. There, the whatever the load occurred here on the building is a constant load. Means constant stresses are there, but right is a constant stresses. The ability of material to deform permanently under the influence of mechanical stress is a time dependent one. It occurs a result of long term exposure to high levels of stresses that are below the yield strength of the material. Okay, this is the difference between fatigue and creep. Another best example, you can take the creep. For a creep also, if you take a shirt also, if you buy a shirt, newly you purchase a shirt, after 4 or 5 years you can see how the shirt is damaged. That is depends upon what property here, the creep. Next one is another very important property is resilience. Resilience are nothing but if you apply a load, tensile load or even compressive load up to elastic limit, what happens? The energy is stored in the body, right? That property we call as a resilience. If you remove that load, it comes back to original shape and size. That is elastic limit. But resilience are nothing but here the ability of material to absorb energy when deformed elastically and return it when is loaded. For example, you can see the stress strain diagram here. This one up to elastic limit. You can see that stress strain diagram. Stress is linearly proportional to a strain. You can say that what is the energy contained in this body here. There is the area under this curve. Now, best example here. You can see this the stress strain diagram. What is the area under the curve up to elastic limit? O A and this vertical line from this. This is a green color, I think, right? This is the area under the curve. Which area it is? What shape it is? A triangular shape. What is the area of the triangle? Half into the base into height, right? That is the area of the triangle. You can see that. How do you measure the energy, strain energy or resilience here? Half into the base into height. That is half into sigma into epsilon. Now apply the Hooke's law. What is Hooke's law? States that stress is directly proportional to strain. Sigma is equal to E into epsilon. From that, substitute epsilon is equal to what? The sigma by E. Substitute here, we will get sigma square by 2E. That is, what is the unit here? Newton meter, or it's a unit of joule, right? That is the strain energy formula. Now, what is the property here? The ability of material to absorb the energy when it is deformed elastically, and if you unloaded it, it returns to it, means it releases that energy. That property is called as a resilience. Up to which point here? Elastic point. Okay, once it crosses elastic point, if it comes to up to fracture point, means what is the area under the curve? O, A, B, C, D, E. This area under this curve is called as, that is one more property, is called as a toughness. It reaches both elasticity and also plasticity. The next slide I will explain that one. Next, what is it? What is its importance? The resilience importance. Okay, how do you measure here? It is expressed by area under elastic region in the stress strain diagram. Again, area under the elastic region. See that it is a what type of what shape it is? A triangular shape. What is the area of the triangle? Half into base into height. Suppose if you take this is per unit volume, that is a modulus. Modulus are nothing but constant. Constant of resilience is nothing but is the strain energy stored per unit volume from zero stress to up to what stress? Yield stress, right? That is called as a modulus of resilience. This is a very important term. It is represented as Newton meter per meter cube. That is a unit volume. It is strain energy stored per unit volume. Now this is the another property, and one more is toughness. Toughness is nothing but here in resilience. What is energy stored here? Up to elastic limit you consider. Once it crosses elastic limit, this is the plastic region. This is the elastic region. This is the plastic region. What is the energy stored? Both the elastic and plastic region. Then before going to its failure, that is called as that energy called as a toughness. Toughness is the ability of material to absorb energy in the plastic range. How do you express here? It is expressed by the area under the elastic and plastic region in the stress strain diagram. See in the stress strain diagram, you can see in this here, or you can see there O, A, B, C, D, E. And from the E vertical line here, that what is the area under this curve? That is called as a toughness. If more metal is more tough, means that is more, it stand more load also, right? Then modulus of toughness is nothing but it is a strain energy stored per unit volume from zero stress to fracture zone. Which energy here? Up to the plastic region, elastic and plastic region, how much strain energy is stored per unit volume from zero stress to fracture stress. Then how do you measure here? You can see that in the stress strain diagram, up to elastic limit it is a linear here. You can get the shape, that is a triangular shape. You can see the O to OA up to E. Now this is not a regular shape, but I want to go for take the area under this curve, means then you go for integrate from 0 to, that is 0 strain to the what is the strain occurred at the fracture strain. That is the integral 0 to integral term. That is y-axis is stress, x-axis is strain. That is the independent variable is strain sigma into d epsilon. What is the integral term here? 0 to epsilon f. Epsilon is nothing but strain, f is nothing but at fracture point. When you go for apply the integral term here, then simplify. Finally, we will get this is the equation. It is the half of the sum of yield stress and ultimate strength, and multiply the strain at the fracture point. That is also measured in Newton meter or joule. Where epsilon f is nothing but strain at fracture point. Sigma y is nothing but the yield stress in Newton per millimeter square. Sigma u is nothing but ultimate stress. Okay, one more important last property is brittleness. Brittleness, ductility we explained, if you when you apply a load, it continuously deforms. But brittleness, the ability of material breaks with a little elastic deformation or without significant of plastic deformation. For example, if we take this chalk piece, I think chalk piece is visible. If someone give me the response.
Yes, sir, it's visible.
Yeah. Now just check a chalk piece. Now apply a load here. What type of load here? Tensile load. If you apply a tensile load, it breaks here. Now whether the chalk piece undergo any deformation here?
No.
The chalk piece will not undergo any deformation. You can see that the fracture is occurred here. Without undergo deformation, without undergo any plastic region, the ability of the metal is breaks without undergo any elastic deformation or significant. That property is called as a brittleness. Best example, take glasses, cast iron, ceramics. Okay, these are the 12 important mechanical properties, not metal, mechanical material properties. You can see the stress strain diagram here. For ductile material, means continuously ability to deform. For ductile material, this is the undergoes both elastic and plastic region. There's a curve, there's an area under the curve, absorb the energy, there's a toughness, right? Up to elastic limit in nothing but resilience. If you take brittle material, this also undergoes small deformation without any intimation, without undergo any plastic region, that it will failure. That is called as a brittle material. Brittle materials are cast iron, glasses, ceramics, etc. But ductile materials are mild steel, take aluminium, copper, all are comes under ductile material. Ductile material is nothing but if you apply a load, its ability to deform continuously, that is ductile in nature. Brittle material means ability of metal does not undergo any deformation, suddenly it failures without undergoing any plastic region or plastic deformation. That is called as a brittle material. You can see that this slide here, strength shows in a subject to an tensile load or compressive or shear load. That is what is the stresses induced here. Maximum stresses induced in the body before undergo its fracture is called as strength. Hardness is nothing but the ability of the material to resist the indentation, the scratch or indentation or penetration. That material is called as a hardness. Best example I can give the car body. If you take car body, if you press here, the indentation, the car body undergot, what happens? There is indentation occurred here, right? Ductility means the ability of metal continuously deform, then form into thin wires. Stiffness is nothing but the ability of material does not undergo any deformation by applying a load, does not go any deformation. That's called stiffness. Toughness means ability of metal to absorb the energy both in elastic region and plastic region completely undergo its failure. That how much energy it absorbs, that shows the toughness. Now these are, you can see the, if the material is ductile in nature, you can see the how the material is fracture occur here, cup and cone shape. Here cup here is a cone shape. There's a once you conduct, well, conducting material comes to material testing lab, when you conduct a tensile test on the mild steel, you can see this type of fractures occur. Is a cup and cone shape. What is if it is brittle material? There is no cup and cone shape here. See the chalk piece also. There is no cup and shape here. The shear occurred here. There is no deformation here. Shear is occurred. There is no change in shape here. It is okay. These are the 12 very important material properties. What are the first one is strength. Second one is stiffness. Third one is hardness, and fourth one is ductility. Fifth one is malleability. Sixth one is elasticity. Seventh one is plasticity. Eighth one is fatigue. Ninth one is creep. 10th one is resilience. 11th one is toughness, and 12th one is brittleness. Then how do you get these material properties of the material? While conducting a test, when it comes to material testing lab, we have a material testing lab in this semester. We're going to apply a load on the body, then you'll go for record it. We'll go for while conducting the test. What type of test here? It is called as destructive test. We call it. Destructive means you're going to collapse the material. Okay, means you apply a load, once completely it collapse, it failures. Up to that, we'll conduct the test, and then you study the how the material is behaves, right? So why do you want to know these mechanical properties? I want to know how the material is behaves when it's subject to an external load. Then only you can easily apply that material for particular that component to fulfill the needs or to satisfy or to withstand the load. Right? For that we use this. We should know these mechanical properties. Yes. Any doubts regarding mechanical properties?
No,
Any
sir.
doubts are there?
No,
No
sir.
doubt? Yes?
No, sir. No doubt.
No, sir.
Okay.
No, sir.
Okay. Now you see that one by one I'll ask here. Now which figure will come which type of property? Okay. Aradhana, yes, is there?
Yes, sir.
Yeah. Now you can see the figure number 1. Right? You can see
Yes,
the figure
sir.
number. Is it visible?
Is
So
that
what
a
is the figure 1
construction
contents here?
building?
Yeah, building, the collapsed buildings. When you go
Yes.
for construct the buildings, they collapsed here. Now,
Okay,
what
sir.
type of property will come here?
Fatigue.
Fatigue means there is no cyclic load here. The
Okay.
building subject to what type of load? It's a static load, steady state load. When you go for construct here, collapse means whatever the strength of the material is not able to withstand that. That's why they collapse. Right?
Yes, sir.
Okay, now this building collapse that shows the material having less strength. Whatever the composition, the material they use, having less strength, right?
Yes, sir.
Suppose they use TNT steel rods, not a high-graded TMT steel rod. They go for construct multi-story building. They're not, the steel rods will not withstand that. Whatever the concrete they're mixing, they are also not withstand that load. Means definitely they go for collapse here. That the building will not withstand that load. Means it comes under what type of metal property here? Strength. These are newly constructed building, right?
Yes, sir.
Yeah. Okay. Next, Pratik Anand is there.
Yes, sir.
Pratik Anand. Yeah. Now tell me figure number 2, man.
Yes, sir.
Yeah. Now it is see the figure number 2. Is it visible?
Yes, sir. It's not clear, sir, but visible, sir.
Visible. Okay, if I go for slideshow, whether it is visible, I don't know. Okay, now this is the what is the figure 2 is there. They're doing conducting the test. That is called as actually beam it is. They're applying a
Yes, sir.
load perpendicular to beam. The
Yes.
material will not able to deform here. That will break here. See the break is occurred here.
Yes, sir.
Yeah. Now which property it is?
Sir, toughness, sir, maybe.
Not toughness. The ability
Brittle,
of
brittle,
material does not undergo any
brittle,
deformation by applying load.
brittle, sir, brittle.
No, not brittle. It does not undergo any deformation when you apply a load. The ability of material withstand a load without undergo any deformation. What is the second property I told here? Second mechanical property. Here is a deformation takes place. That's why it deformed here. That's why it is failure here. That is called as what is second mechanical property? First mechanical property is strength. Second one is
Stiffness.
yeah stiffness. The stiffness here. The stiffness property will come here. Now the next one, Deepak CS is there. Deepak CS, US number 4. Next, Hitasham. Hitasham,
Yes,
right?
sir.
Yes,
Yes, sir.
US number 6. Now tell me the figure number 3. Here the component is there. Over the component, a ball is come and placed over here. What is this called as?
Elasticity.
Sorry?
Elasticity, sir.
See the figure properly. A ball is there, come and place over here, then apply force and remove the ball. You can see in this figure number 3, the first figure shows the ball is placed over here. Second one figure, load is applied.
Compressed.
Third, if the ball is removed here, what here images you can see that?
Elasticity, sir. It regains its original state.
No. It is called as what is called as a penetration. The ability of material to resist the penetration or indentation we call as.
Resistance.
That material
Resilience.
property is called as
Resilience.
not sorry, not resilience.
Variability.
It is a hardness, right? Yes or no?
Sir, that is rubber ball. No?
Ability of material to resist the penetration or indentation or abrasion. That is called as a hardness. Next, Grishma.
Yes, sir.
Grishma
Yes, sir.
Grishma is there?
Yes, sir.
Now tell me figure number 4. I think very easy task you got, man.
Ductility.
Yeah, ductility. No, initially it is material here. If you apply a load, tensile load, it become what here? Thin wires. That property called as ductility.
Ductility.
Now these are the figure number 5 shows again the what are the wires you can see that the wires having what property here? Ductility property. Now I'm explaining only mechanical properties, not other properties. Chemical, physical, or one more is dimensional property, right? We are discussing only here mechanical properties. Now these are the example for a ductility: wires, thin wires, electrical wires, cable wires. Next, Lahari G. Lahari G is there?
Yes, sir.
Lahari G. Now see that this figure number 6. Again on the figure itself is there. Yeah, what is this?
Elasticity and plasticity.
Yeah, plasticity. In elasticity, what component the fingers having? What is the material? What is the component is having here?
Rubber band, sir.
Rubber band, right? Yeah, rubber band having elasticity property. Elasticity means if you apply a load, it continuously deform. If you remove the load, it come back to original shape and size. The property called as elasticity. Now one more is there. Below that you can see that this is the plasticity. Plasticity, what are the examples here? What are the components here?
Yes, sir.
What are these? Yes?
Clip, sir. Pen hold. Paper
That is a
holder.
paper clips you called as Lahari. Paper clips. So paper clips under plasticity region. Sorry, plasticity.
Sir.
Okay, the slide is coming out here. Is the slide is visible? Okay, 1 minute.
Yes, sir.
Yes, sir, it's visible.
One minute. Now the slide is visible. Yes, someone has to give the response.
Now, not, sir.
Lahari,
No, sir.
slide is
No,
visible.
sir.
No, sir.
No, sir.
Lahari,
Yes, sir.
yes, anyone can give the response. Slide is visible.
No, sir.
No, sir.
Yes. The slide is visible.
No, sir.
No, sir, slide is not visible.
No, sir.
It's not coming only, sir. It's not visible.
Yes, anyone can give me the response.
Slide is not
No, sir.
visible.
Slide
It's
is
not
visible.
coming.
No, sir.
Yeah,
It's
in
not
plasticity
coming.
you can see the paper clips. Now paper clips already undergo a plastic limit. Now if you unfold it, it will not regain its original shape and size. Sorry? Yes. Any doubts?
No, sir. But the slide is not visible.
Someone has to give me the response.
Hello, sir, slide is not visible.
Manoj K.
Sorry.
Manoj K is
Yes,
there?
sir. Yes, sir. Yes, sir. Hello.
Yes, Likita and
Yes, sir.
yeah. Now tell me the figure number. So sorry, figure number
Seven.
7. Which comes under
Fitted.
which? Yeah, it is a shaft, crankshaft. While it's rotating, it failures.
Fitted, sir.
Fatigue. Good ma. Is the ability of material to failure. The maximum stresses occurred in the material of the failure occurred due to a cyclic load. That is called as fatigue. Now, Pradeep K. Is there?
Yes, sir.
Yeah. Now tell me the figure number 8 is a spring. When you compress the spring, it will deform. It's a shorten its length. If you remove it, it comes back to original shape and size. When you compress it, what happens? The spring store the energy, right?
Yes, sir.
Yeah. What type of property it is? It store the energy.
Sir, elasticity.
When you apply a load, when you compress the spring, then hold here. It will store the energy in the spring. If you remove it, if you remove the load, it comes back to original shape. It releases the energy. The energy stored here, strain energy is absorbed when you apply a load. If you remove the load, the strain energy is released. That what type of property it is?
Resilience, sir. Resilience.
Resilience. Within the elastic limit, it comes to original shape and size, and that is the elastic limit. Good mark. Next one, Tejas AV. Tejas AV.
Yes, sir.
Yeah, now figure number 9 is a glass, wine glass, right?
Yes, sir.
Yeah, now if you apply a load on the wine glass, see that whether it is undergo any deformation, any change in dimension takes place.
Yes, sir.
Finally, again, if you increase the load, it comes to collapse here. What type of property it is? Glass. Glass comes under what type of property?
Brittleness. Brittleness.
Brittleness. Good. Okay, someone other one has given the answer. Good. It's a brittleness. If you apply load on the glass, wine glass, it will not undergo any change in dimension. It will not undergo any deformation. Then once it reaches plastic range or plastic limit, it will collapse here. That is called the brittleness. Now last one, Yogish P is there. Yogish P. US number 29. Okay, anyone can give the answer. Figure number 10. Your truck is
Creep.
moving over the
Creep, sir. Creep.
bridges. Now see the bridge is
Creep.
slightly bent here. Again, this is a old bridge, not a new constructed bridge. It will come under which
Creep,
property?
sir.
Creep, sir.
Creep.
Yes, good, ma. Now I think you understand the mechanical property. One is strength, stiffness, hardness, ductility, and malleability. I have not shown here. That is the form into thin sheets. That's the plates, steel plates we take, or what we call as steel plates or any paper plate we can take here. Those are comes under malleability. Then elasticity, plasticity, fatigue, resilience, brittleness, then creep. Okay. Yes. Any doubts?
No, sir.
Yeah, how much time we have? Now 12:30. Shall I continue or next class we'll go for this?
Next class, sir. Next class.
Next class. Okay. If you have any doubt regarding these mechanical properties, then you can ask me in the next class. Again, before coming to that next class, so each student has to give two components having any two material properties, mechanical properties. For example, in a house, okay, anybody, okay, in a house, best give that one example here. Take a vessel. Okay, vessel comes under the steel vessel. The steel vessel comes under what type of property it is? Yes, anyone can give the answer? Steel vessel.
Strength.
Yeah, not strength. Steel vessel. Okay, it is also having a strength. Comes under ductility usually, right?
Yes, sir. Ductility.
Yeah, if it instead of steel vessel, if it take mud vessels, right?
Brittle, sir.
Otherwise,
Brittle.
in
Brittle.
olden
Brittleness.
use, yeah, brittleness, right. Likewise, in your homes, see the appliances, things are there, see the material, that material comes under which property. So each students have to give two examples, different examples, same example don't give. Okay, in next class, we'll start some mechanical members are there. Okay, bars, beams, trusses, shafts, columns, then we'll go for discuss the syllabus. Because if you know these are new terms for you. If you know these things, then only I can tell we can overview the syllabus. Okay. Yes. Any doubts? Any doubts is there? You can ask me.
Hello.
No, sir.
Yeah. Yes. Ask any doubts, ma'am. No doubt. Shall I stop here?
Ah, yes, sir.
Oh, okay, good.
Yes, sir.
ma'am. Okay, thank you guys. Thank you for attending the classes. Next
you,
tomorrow, morning first hour is there. Be prepared and come. I will ask anyone for mechanical properties and also two examples for that. Okay. Okay.
Yes, sir.
Thank you guys.
Thank you.